We are going to go ahead and start chapter 5 with 5.1, polynomial functions. And I want to start with the vocabulary because the vocabulary is really crucial for this chapter to understand exactly what we're talking about. Because we'll be using these words and you need to know what those words actually mean as we go through this chapter. So I want to start with the word monomial. Monomial, like the word mono means one. So monomial is usually a real number, variable, or the product of a real number and one or more variables with whole number exponents. So for example, something like the number 5, that's a constant, that's a real number. Okay, maybe x, that's a monomial, that's a variable, or the product of those numbers. Okay, it's never any addition or subtraction, it's always a product of real number and one or more variables with whole number exponents. So I may have something along the lines of 25 x squared y z, and that is also a monomial, even though we have lots of different things in it. We have a constant, we have an x squared, we have a y, we have a z, but they're all multiplied together. So those are all examples of monomials, no addition, no subtraction. Okay. The next term is the degree of a monomial. Well, in one variable, the degree is the exponent of the variable. So notice it's in one variable. So we determine a degree, something like this. Okay. This would be a second degree monomial because it's x squared. So it's always the exponent of the variable. This would be a fourth degree. Okay. We might call this a quadratic. We might call this a quartic because of the degree. So it's always the degree of the exponent of the variable. A polynomial, okay, where unlike a monomial where mono means one, polynomial, poly means many. So a polynomial is a monomial, even though, yes, it's one, we still consider it in the polynomial family. But generally a polynomial is a sum of monomials. So this is where the addition or subtraction comes in because again, sum doesn't necessarily mean addition. We could be adding a negative number. So examples, obviously a monomial, so I'm going to just continue with my 5x from above. A binomial would be two monomials. Okay, a binomial is a specific polynomial where it might be something like 5x plus 7. It could also be x squared minus 2x. Okay? Those are all examples of binomials because there are two terms with addition or subtraction in between them. So there are two monomials combined together with addition or subtraction. A trinomial, well, tri means 3, so we would obviously have 3. So it could be like 5x squared plus 2x minus 6. That would be an example of a trinomial. We have 3 monomials combined together with addition or subtraction. Okay, so moving on down. A degree of a polynomial is our next term. The degree is kind of like what we talked about with the monomial. In one variable, the greatest degree among its monomial terms. It's the largest exponent in the polynomial. So for example, a quadratic, which we've been studying, would be like x squared plus 6x minus 2. Okay, this is a trinomial, but it's a polynomial. It's just a specific polynomial with 3 terms. The degree would be second degree. And since it's a second degree, it has a specific name called the quadratic. Now, normally quad means 4, but anyway. So quadratic is the specific name for a second degree polynomial. If we had something like x cubed minus 4, again, this is a binomial because it has 2 terms, so it's a specific polynomial with 2 terms called a binomial. However, because my largest degree or greatest degree is third degree, but the specific name for a third degree is called a cubic function. So we have a quadratic function here, we have a cubic function here, based on the degree. So next vocabulary term, polynomial function of x. A polynomial with the variable x. That means that we have one variable, generally it's x, function of x, and the degree of the polynomial function is the same as the degree of the polynomial. That's basically where it's dealing, I'm not going to put any examples. All of these up here are examples. We just consider them functions. They might be written as f of x equals, and then you'd write your x squared plus 6x minus 2. So when we talk about a polynomial function, that's all we're talking about. So the next step is classifying polynomials. This is a chart that I think will be very handy to you. So let's make sure we go through it and you get everything down onto this chart, because you are going to be asked to classify them and understand them when I say, or when you hear a quadratic function or a cubic function or a binomial or a trinomial. You need to understand what those terms mean. So here's our degrees. We've already listed the degrees, 0 through 5, meaning, as you can see, there is a variable. Basically, we could look at it like this: x to the 0 power. You don't have to write that, but our degree is 0. We have no variables, because anything to the 0 power is 1. It doesn't really exist. In other words, we have 0 x's. So the name using this degree is just called a constant. A 0 degree polynomial is a constant. Okay. This right here is called a linear. Okay, and we've done this. This is like x to the first. Understand there's an understood 1 there, x to the first plus 4. That's just a linear function, a linear equation. Okay, a degree of 2 right here, this x squared, means it's quadratic. Right here we have a greatest degree of 3. That means it's a cubic. These are all specific names using degrees. The largest degree here is 4. This one's called a quartic. Okay, and then when we have the greatest degree of 5, this is as far as we're going to go. This is called a quintic. Okay, so there's kind of the names of each ones. The ones we'll focus on probably most often will be these 4 right here. We will focus on probably those 4 throughout this chapter. Now let's look at the number of terms. We can name them a little bit differently using number of terms. I'm going to go ahead and list this whole column. This has 1 term, just the 5. This has 2 terms, the x plus the 4. The 4x squared, again, just has 1 term. There's no addition or subtraction. It's only multiplication. The next one has 3 terms, because we have 4x cubed, and we have a 2x squared, and we have an x, all combined with subtraction or addition. The next one below that has 2 terms. And then this one down here has 4 terms. Okay? So let's talk about this with terms. Instead of calling it bilinear, quadratic, cubic based on the exponent, let's call it based on the number of terms. So this is just a monomial. Okay? The one with 2 terms will be called a binomial. Okay? The one with 3 terms would be called a trinomial. Okay, we haven't gotten there. We're back to the 1 term. The one with 1 term, again, is a monomial. Okay? The one with 3 terms, yes, this one is a trinomial. I want you to go ahead and pause the video, see if you can figure out the last 2. And then we'll see if we can decide if you guys are correct. Okay? All right, 2 terms, definitely binomial. And what about the last one? We haven't really talked about that. Well, there's no specific name for one with 4 terms. It's just called a polynomial. So anything beyond a trinomial is called a polynomial of however many terms. So this one would be called a polynomial of 4 terms. I didn't know if you guys might try to guess that one or not. But a polynomial of 4 terms. Okay, so kind of make sure you understand the difference between the degree and then the number of terms. Okay, because they are different, and how we might call them. We might have a trinomial that is cubic. We might have a trinomial that is quadratic. We might have a trinomial that's quartic. Okay, we might have a trinomial that has the greatest degree of exponent might be 9. So we can have a trinomial of 3 terms where the degree is completely different. Okay, all right, moving on down. Standard form of a polynomial function, well, we kind of talked about that with quadratics. This is the key, arrangement of the terms by the degree in descending numerical order. So if you were to have something where you have, say, x to the 5th plus 2x to the 4th plus 3x squared plus 4x cubed minus 2x plus 7, okay? I would look at this and I would go, okay, well, my greatest degree is a 5. The next one is a 4. But then my next greatest degree is a 3. Okay, so I have this x cubed here. So, and I know you guys know this, but I would need to switch these two to make them in standard form. So I would need to switch those two because I need it to go 5, 4, 3, 2, 1. And not all polynomials will have, oh, I forgot my numbers. We'll just make up something. 3x cubed plus 4x squared plus 2x minus 7. I'm not sure what it was. It was something like that. But not all of them are going to have each exponent. You may not have a 5, 4, 3, 2, 1 for your exponents. You may just have a 5 and a 2 and a constant. Just make sure that they are in descending numerical order, and then you have them in standard form. So please always check that, because when you're trying to solve certain things, you need to have them in that descending order, not just mixed up. And the next one is turning points. We'll talk about those later. Places where a graph of a polynomial function changes directions. We'll talk about that. I can't really do examples because we're going to talk about that within a graph. Okay. The last thing I want to talk about on this video is the end behavior. Okay. So I really want you to focus on this. Directions of the graph at the far left and the far right. That's your end behavior. What is happening on the end behavior? So here's what we want to look at. Remember when we have an A. Your A is always your leading coefficient. So it's going to be the coefficient of the term with the greatest degree, or the largest exponent. So your leading coefficient is always going to have your A. Okay, and we'll talk about that when we get down to the examples down here. So if your leading degree, that means your largest exponent. Okay, so your largest exponent, if your largest exponent is even and your A is positive, here's how your graph is going to look. The end behavior is going to go up and up. Okay, if your leading degree is even, or your largest exponent is even, but your A is negative, you're going to go down and down. Over here, your leading degree, again, largest exponent. If the largest exponent is odd and your A is positive, you'll go down and up, and the A is negative, you'll go up and down. So let's kind of check this out down here in these examples. So right here, I have my largest degree is a 4. So my leading degree is even. So leading degree even. And my A is positive. It's a positive 4. So notice, leading degree even, A positive, that means I should be up and up. And notice, look what's going on. My end behavior is, my graph is going up and up on each side. Okay? Over here, this next one. Again, leading degree, I'm just going to say LD, is even. But my A is negative. So this time, instead of at the up and up, my leading degree is even, but my A is negative. So I should be down and down. And I am. Down and down. Okay? The next one. This time, my leading degree is odd, but my A is an understood positive 1. So my A is positive. So in this case, I'm over here in the odd, and my A is positive, so it should be, my end behavior should be down and up. Okay? And then my last one, right here, my leading degree, again, is odd, but this time my A is negative. So I should be at the up and down one. So if I'm at the leading degree odd, A negative, my end behavior is up and down. Notice it's always from left to right. So far left and the far right. It always goes left to right. So left is always listed first, the left behavior is listed first, and the right behavior is listed second. Okay?